Hello, my name is Leah Torres, and I'm a biomedical engineering major from the class of 2019. We will be working through problem number 4 from chapter 2.3 in the general chemistry workbook. You should begin by working on the problem yourself to see if you get the answer. Please pause the video now until you have completed the problem. Then we'll go over it together. This problem deals with isotopes and ions, which are atoms with varying mass numbers and charge. I will elaborate on these shortly. You should note that sometimes an atom can be both, as shown with element X. The lower left number, A, is the atomic number, which is the number of protons. This never changes between atoms of the same element, and thus it does not need to be shown all the time. This is an excerpt of your periodic table. I've chosen carbon because it is an atom that you are probably familiar with. Carbon's atomic number is 6. In this specific drawing is in the upper left-hand corner, but sometimes it's located up at the top right here. The next number I would like to discuss is the mass number, which is shown as B. It is shown in the upper left-hand area of the element symbol. The mass number is the number of protons plus the number of neutrons in the specific atom. When the mass number varies, you have different isotopes. The third number on this schematic, C, is the charge number. C itself shows the magnitude of the charge, while the plus or minus shows the type of ion it is. A positively charged ion is also known as a cation, whereas a negatively charged ion is called an anion. A cation with the charge of positive C has C fewer electrons than protons, whereas an ion with a charge of minus C has C more electrons than protons. If there are the same number of protons and electrons, the atom is neutral and C is not shown. These problems are pretty straightforward and only require some quick calcs. By the fifth example, it should feel like you're doing the same thing over and over again. Let's do some examples. We'll start with part A. For each of these problems, we need to calculate how many protons, neutrons, and electrons each atom has. So let's start. Here, for part A, we have carbon with a mass number of 12 and no charge, as shown by the absence of an upper right-hand number. Since carbon always has 6 protons, we can subtract 6 from 12 to get 6 neutrons. And the fact that it's neutrally charged means that there must be 6 electrons. So in this atom, there are 6 protons, 6 neutrons, and 6 electrons. Part B is much like Part A, except that the mass number is 13. That means that this specific atom is an isotope of Part A's atom. Since the number of neutrons is the mass number minus the number of protons, there must be 7 neutrons. Remember, the number of protons doesn't change, and the fact that this atom is neutral, it has the same number of electrons as protons, giving us 6 protons, 7 neutrons, and 6 electrons. So part C gives us an atom of a different element, xenon, with a mass number of 133 and no charge. When we look on our periodic table, we see that xenon has 54 protons, meaning that with a neutral charge, it must have that many electrons. To get the number of neutrons, once again, we subtract 54, the number of protons, from 133, the mass number, to get 79 neutrons. This gives us 54 protons, 79 neutrons, and 54 electrons. So now we have an atom that is both an isotope and an ion. Remember, it is an ion because there is a number on the upper right-hand side of the element symbol. That plus sign is a +1. Let's start by finding the number of protons, which when we look up potassium on our periodic table, we find out that there's 19. Since the mass number is 40, there must be 21 neutrons. This specific potassium atom is a cation, meaning that to get the number of electrons, we must subtract the charge number from the number of protons, giving us 18 electrons. So this specific atom has 19 protons, 21 neutrons, and 18 electrons. We are going to skip part E because it's just like parts A and B, but with silicon. Part F has a sulfur ion with a -2 charge and an atomic mass of 32. According to our periodic table, sulfur has 16 protons, so it must also have 16 neutrons. The -2 charge indicates that it's an anion with 2 more electrons than protons, giving us an atom with 16 protons, 16 neutrons, and 18 electrons. Part G gives us carbon, but with a new notation. It is written as carbon-14. The 14 is its mass number. Since we know carbon has 6 protons, we subtract 6 from 14 to get 8 neutrons. There is no charge indicated, so we assume that it's a neutral atom, meaning there must be 6 electrons. So there we have it, 6 protons, 8 neutrons, and 6 electrons. We are going to end here. These 6 parts, A, B, C, D, F, and G, should give you a good survey of the various problem types pertaining to this topic. Thank you for listening.